DJI's latest agricultural drone. The MG-1P series supports multiple aircraft's control from a single remote controller. One pilot can simultaneously control up to 5 aircrafts with a single remote controller, reducing operational cost and completing more tasks in a shorter time frame. The spraying system uses aerospace composite materials that resist corrosion and double surface life. Leakage-proof nozzles can be started or stopped in just half a second. A 5-meter spraying width lets the MG-1P series cover an average of 6 hectares per hour. Dual searchlights help ensure safe operation in low light. With a 123-degree wide-angle camera, directional radar system that integrates 3 high-precision detection radars and 1 obstacle avoidance radar. It can detect objects as small as a half a centimeter power line from up to 15 meters away. An onboard FPV camera lets users record waypoints during flight, facilitate route planning, and avoid the trouble of manual recording to increase efficiency and save time. It also analyzes the terrain to adjust aircraft altitude to achieve safe operation. The radar system is protected by IP67 casing for an all-weather durability and convenient maintenance. Low-altitude flight can be controlled from up to 3 kilometers away, while ensuring stable communications in even complex operation environments.
A drone became an inevitable employee in every logistic organization. It is super interesting to visualize the commercial world with the intelligent machines. Drones are the compact machines can able to carry the cargo to any parts in the urban space with a less time frame, that is 1/3 of its actual delivery time. In this video, we are going to discuss on what is drone, how drone navigate itself, essential hardware used in the drone, courses taught in relevance to the drones, drone application areas.
What is drone?
Drones are unmanned aircraft flying at lower altitude, controlled either by remote user or by automated system through satellite systems. Drones are the significant employee of logistics field since pandemics hit globally. Drones are used for delivering packets of 1 to 5 kgs of medicines and cargoes to the remote recipient. It can send alerts to the customers when it reaches the location of recipients. Drone flying objective is: it need an inbuilt counterweight mechanism against opposing wind currents. Based on the wind currents, the flying velocity of the drones are determined. To fly seamlessly, Drone need a constant eye on flying landscapes, either hills, valleys, skyscrapers and on. Moreover, it demands a constant signal connectivity with the remote user on landing and takeoff decisions.
Essential hardwares in drones. All about drones presentation is prepared based on the information of this book.
This book captures all latest information of how drones and robots are used in logistics for extra miles. Revenue generated, jobs available, future direction of logistics and on. To purchase this book, available in soft, hard copy, you can scan QR code. It is also available in Amazon.com and Amazon.in.
The hardware used in the drones are less than hair size. It is equivalent to the size of the microns. Some of the hardwares which are essential to the operation of the drones are PLC circuit, which can take autonomous decisions, and with the 4 batteries, and it can able to propel itself with the 4 rotary blades on its corner, along with a small cabin size to carry the cargo to the distant place.
Drones essential hardware.
Durable materials within slot to accommodate payload.
GPS devices to send the existing flying location of drones. Camera to monitor the flying landscapes. PLC circuit for automated decision-making on flying trajectory. Gyroscopic sensors are required to balance the wind force.
Fast recharging batteries with leak proofs.
Drones can be effectively controlled and regulated its flying pattern by 2 layers of controlling mechanism. The first layer have a MEMS sensor which can able to capture 4 parameters by using accelerometer, gyroscopic sensors, magnetometer and barometer. Whereas the second layer of operating mechanism is focusing on autonomous flying pattern. It can be effectively executed by using Kalman's algorithm. This algorithm extracts all the data which is stored in the sensors and it converts as a useful data for flying pattern. Say for example, if the wind velocity is high, the past data of the wind velocity can be used for regulating the flying speed and velocity of the drone. So the past data can be converted as a input for the present flying pattern.
Drone navigation mechanism.
Drone operates on 2 layers of control mechanism, and they are: first stage of controlling unit, recording the flying parameters with the essential sensors.
Second stage of controlling unit, decisions on navigation path trajectory.
Drone controlling mechanism.
First layer of control mechanism. The primary layer of drone control mechanism are regulated by MEMS sensor. MEMS is micro-electro-mechanical systems with less than a micrometer in dimension. It has the ability to perform seamless operations at low power in IoT platforms.
MEMS sensor has 4 unique devices operate parallelly to record data of flying space, and they are: accelerometer, gyroscopic sensor, magnetometer, barometer.
Accelerometer.
When the drones are flying in the opposing wind force, the interspatial gap between the capacitance plate varies, and in turn it provides proportionate effect in input signal, electrical volt change. The signals of the wind are then feedback into the controller. 3 axial accelerometers are placed to measure the counterforce in all 3 directions. Accelerometers are used for measuring the navigational flight altitude.
Gyroscopic sensor. It is used to measure the rotation of the blades, RPM. It regulates to generate counter force according to the wind flow direction.
Magnetometer.
These sensors are used to capture the flying landscape. Whether metals, mountain barriers obstruct the path of the flight. Based on these input, the flight navigation algorithm generates autonomous decision during flying hours.
Barometer sensor.
Barometer sensor used for measuring the pressure drop on its flying space, thereby it can understood the flying height from the grounds. These sensors are used as a flying height measuring device.
Second layer of control mechanism. Sensor fusion technique.
Drones flying within the space of around 2 kilometers can be managed by local positioning unit of drone control kits. If the flying radius exceeds 2 kilometers, then local positioning unit would be transformed into global positioning unit, GPS, of satellite along with radar signals. The accuracy of GPS is limited to plus or minus 20 meters. To calibrate these error, radar signals are used to have minimal error and maximal precision. Kalman filter is used in the device where uncertain information is highly prevalent and for the dynamic objects. Drones, robots. Moreover, drones flying for longer distances with the hilly landscape needs decision support to change its flying path. Therefore, these algorithm records the position and flight velocity data constantly into its database for further navigation flying pattern. Kalman flying algorithm has 3 main blocks, namely, past data, xk1, present data, xk, and future data, xk plus 1. The past data includes flying parameters such as wind, velocity and flying landscape, to sense any barriers, hills, skyscrapers, and it will alter the present flying projectile. Based on the past data, and simulated data profile will be generated and it will be calibrated with the present data. This cycle will be continued seamlessly until it reaches the destination.
Resources on logistics.
Latest blogs. Study videos. E-books. E-magazines, Logistic edition monthly. All these resources are available in https://logistic-researcher.weebly.com. Record your comments below and click the like button.